afternoon, everyone. I am Dan Giralte from the Capacitor team. I'm the lead native engineer here at Ionic, so I oversee the Capacitor and the Portals teams. And I'm here with Joey, who's one of the engineers here, Dallas, who's the engineer, the project manager, and Logan and Connor, who are here to help out with the stream. So welcome.
Hey everyone, we're excited to be on live stream again today. We've been doing these all month long for Capacitor, and today is our third and final one. And wow, are we excited for what we've got going on today. Yeah, it's going to be really good. We're excited to have everyone.
That's right.
Let's see. All right. So yeah, so I think Dan, you went around, gave everyone introductions. Thank you for doing that. So let's just get some housekeeping stuff out of the way. So it's been Capacitor month. We've got all sorts of cool stuff that we've been talking about. Logan, you and I were chatting, before we kicked off the stream here about some of the cool stuff we've done. You want to recap us on some of that?
Yeah, I mean, I would say the best place to check out is definitely our socials, Twitter, LinkedIn. We have tons of stuff on YouTube, but we've done at the beginning of the month, we kicked off our live stream where we kind of talked about doing live streaming, video on demand apps, creating custom capacitor plugins. We've done community highlights, like we just recently talked about Aaron Saunders, who has a lot of great content around anything capacitor, Ionic related, Vue, Vite. So we've just been diving into a ton of stuff. I would say go check out those socials and see what we've been working on.
Yeah, it's been really cool. I think it'd also be fun. We've got people from all over the world checking us out today. Let's say hi to some people. Hello.
Oh, hi from Turkey. Whoa.
Yeah, all the way across the world. It's got to be middle. I feel like it's middle of the night. I don't know what time it is in Turkey. Hello, all the way from Turkey. That's really exciting. And we also have Chris Roth all the way from the Ivory Coast checking us out today, hanging out with us on stream. Welcome. We're excited to have you. We've got Todd Hale from Utah here in the United States.
Exotic Utah.
Yeah.
Got it. We have a few.
A couple of us are going to be in his neck of the woods in the next week or two, right? Because we have NG Conf that's going to be coming up. We're going to be visiting.
Yeah, that'll be fun. Todd, if you're going to be at NG Conf, come hang out with us. That'll be exciting. We've got Ali from Iraq here.
Dang.
Yeah, we're covering the world here. We've got Mark, one of the capacitor engineers from Ionic, all the way from Ionic. Welcome, Mark. Let's see. Calling out a few others here. From Germany, we've got Tiffany from North Carolina. Look at that. We got so many people. We got everyone saying hi. Yeah. Hello, everyone. Yeah, we'll just spend the whole stream saying hello to everybody.
Yeah.
That'd be great.
And actually, this might kind of lead us to a good point. If you guys have any questions, comments, anything like that, during this live stream, definitely ask it, because we do have engineers in the chat that might be able to help you out as we're kind of going through this. And we also have these folks
over here.
Wait. Yep. We definitely have these folks here who can also answer a lot of your questions. So definitely feel free to ask as we're kind of going through this.
Yeah. Today's going to be really exciting. So we are doing, if you've read the title, we're talking about something new, brand new plugin for Capacitor. The goal of this is to kind of dive into the technical details of it, right? So for anyone who, is interested in the code, this is a great opportunity to talk to both Dan and Joey about how and why we've built this and, all of the cool things you can do with it. Which I think leads us really into what we're going to talk about. So Dan, why don't you kick us off? Tell us what we're talking about today.
Yes. So you want to start that presentation? So I guess we're on the second slide here. So we're really talking about we've highlighted background tasks as a single in the titles here, but there's actually two that we're going to premiere today. So if you hit the button and click here.
Yep.
So first off, we have the capacitor background runner. And this has been an often requested feature for Capacitor. The ability basically gives you the ability to run code when the app is no longer in the foreground. And normally, because Capacitor runs in a web view, this wasn't possible. So Joey's going to talk about, and most of this was developed by Joey. He's going to talk about the technology we went into it, how it works. But essentially, it lets you continue to write JavaScript code like you're used to, and still be able to execute things while the app is backgrounded. The background task runner supports both iOS and Android. And right now we support, it does have to be somewhat custom coded to certain specific tasks. So we built a few already existing, but part of this is going to be getting feedback and finding out what you want to see. And so if you click to the next frame here, the other thing we're announcing here is Capacitor Watch. This is a plugin that lets you share your UI or share UI on the watch, and you don't need to know anything about developing on iOS or watchOS. You're still going to write effectively JavaScript that will create a UI on the watch and lets you interact with it. So you'll define your UI in JavaScript code. We kind of have a custom language style that we defined right now that gives you basically lets you build that UI. And you can update the state on the watch with code in the Capacitor app. And you can also have the watch app tell the phone to do something. And right now it's only for iOS. This is a pretty complicated process. But we'll get into specifics, but Android is a maybe.
Yeah. So these are really cool. We're excited for these plugins because background tasks I think has been a long-standing request of anyone using Capacitor or even Cordova long ago, right? There's never really been a good way for web engineers to be able to do this, right? The answer's always been, well, you have to go use native code, right? You have to go configure this in native. Dan, you mentioned that Joey kind of, has spearheaded this. Joey, why don't you tell us, how did you come up with this idea for background tasks?
Yeah, so like you mentioned, one of the common pain points that a lot of developers run into, and myself included, is being able to react to things when your app is in the background. So one of the more common events would be like responding to silent push notifications. So typically you want to do that in order to perform things like fetching data in the background so that it's freshly available to the app when the user returns to the app. Currently with the Capacitor app, if you want to do that, you have to resort to writing native code because obviously the web view isn't going to be awake when your app is launched in the background on iOS and Android. So months back, experimenting with a bunch of ways that we could even get this to happen. And I was sort of inspired by Quick.js, Bun, and a bunch of these new JavaScript runtimes. So I sort of figured, what if Capacitor had its own JavaScript runtime to let us do these things outside of the web view? And that sort of launched what ended up being the background runner.
Yeah, so this is really cool. So internally, a little visibility into kind of how Ionic works from an engineering culture perspective, right? We have our normal sprints where we do, our typical work. We're working on Capacitor, building out plugins, doing anything like that. We also reserve a couple of days at the end of every single sprint for everyone on the team to get out there and just build something, right? We call them our Jedi days. And the whole point is just to get out and try stuff, right? So if you have ideas like, what you're talking about here, Joey, of, what if Capacitor has its own runtime, right? It's time allotted for the engineers to build that, right? And that's kind of how this came about, right?
Yep.
Very cool. Yeah. So let's, I'm excited to kind of dive into this. And I see a lot of people in the comments are also excited about this. Got a comment here from Will. Been waiting years for something like this, right? I think we all have, right? I think this is the sentiment. And this is why we're so excited for this new plugin that we're going to talk about. So let's talk about why this is so cool. So we've got another slide here. Okay? No native experience required. So Dan, why don't you tell us a little bit more about this?
Right. So yeah, when we build these plugins, we're building it for capacitor developers. We're not expecting you to have much knowledge about how to interact with the native side. Just doing at the bare minimum possible. So everything you'll do in your capacitor web app, and plus there's also the option to share code across tasks and watch and other things. So, obviously you have the power of the web and JavaScript, and the ability to structure it the way you need to get whatever you're doing done. And I did put a little caveat here. There is a little bit of things you need to do in the Watch app to make the Watch app work. I'm going to go over a couple of those points. Just it more pointing out how easy we've made it, because you really don't do anything other than add a few lines of code and add effectively a Swift package to get it to work. But I'll show that off in a little bit.
All right. Yeah. So let's talk about kind of this background runner. Joey, why don't you talk us through this code here about, what does this look like? What is all this doing?
Yeah. So basically, the recap, the background runner is essentially a way to let us write and run JavaScript code outside of the web view. So what that does is allows us to basically execute that code in a bunch of different contexts, including in the background or in response to other events. So the runner is event-based, and as you can see in that example snippet there, you register functions for various events, and then the runner will then dispatch events based on things that come in either from the system or from events that you can invoke from your app itself. So if you look at the first example here, so we're basically registering an event listener for the My event. So from your app, you can dispatch an event from your app to the runner, and then it will basically execute this function here. The second example is similar, but this time we're reacting to a system event. So in this case, we're reacting to a silent push notification, or it could be a push notification in general. And as you can see here, you can basically, when you get your push notification in, you can basically perform a fetch and do a bunch of work before completing your function.
Yeah, this is really cool, right? This is, I think, one of the things you alluded to earlier of keeping data up to date while your app's in the background.
Right.
This I think is really powerful, and I can see this opening up a lot of opportunities for applications, right? That are very data sensitive, right? You constantly need that up to date data. There's no longer really a need to have that data update step when your app opens up. You can just keep it updated in the background.
And which leads to the next slide. I can get a little bit more into that. So since the runner can run in any context, we can actually configure the runner to run as a background task on iOS or as a work request on Android. So essentially what you can do is schedule your runner to run every 10 minutes, every hour, every 2 hours. And then when the operating system triggers your event, it will then execute an event of your choosing, and then that will then run in the background based on the rules of the operating system, which we'll go into later. Additionally, so we currently support some of the common web APIs, so things that you would normally expect, like fetch, console log, set interval, set timeout, so on and so forth. And currently we're going to ship with 3 device level APIs that you can access from your runner. So preferences, notifications, and geolocation you'll be able to get access to from your runner. And of course, there are a bunch of other opportunities for more APIs, and based on the feedback from the community, we can consider adding more as time goes on.
Yeah. So can you explain to us just a little bit, you specifically call out that this supports common web APIs, right? Is there a reason this doesn't support all of the APIs, or why is that the case?
Well, a lot of the web APIs probably aren't really appropriate in a mobile context, number one. And then number two, which we'll get into later, the runner isn't long-lived. So some of the additional APIs wouldn't make sense in that sort of context. And we're also running up against limitations of the various operating systems as well. So what we decided to do is basically just implement sort of the common ones first, and then based off of feedback on what packages or code eventually ends up wanting to need, we can implement the rest of them.
Yeah, that makes sense. I remember you showed off a demo of this internally a week or two back using geolocation and preferences, right? Where you had it set up on your phone and it basically tracked your location as you moved about. It looked like you're out running errands or something like that.
Yep.
And it just kind of tracked those, grabbed your coordinates every so often, stuck them in a key value store through preferences, and then you would open back up the application and it had all of those points plotted on the Google Maps plugin.
Right. Yeah, exactly. And again, like you mentioned, the runner stored those points in preferences, which is essentially using the same APIs that the preferences capacitor plugin uses. So the runner can then store it in the background, and then on the quote unquote front end, your application can use your familiar capacitor plugins to then pull that data back out and make use of it.
Very cool. All right. So let's talk a little bit about the architecture of, how this is and why this works.
Yeah. So as I mentioned before, so events can be triggered, or events can come in from two different areas. So let's say you're running a capacitor app and you want to perform work that you've written in the runner. There's a function in the plugin called dispatch event that you can use to basically dispatch any random event and some associated arguments. And essentially what happens is it wakes up the runner, sends the event and the arguments to the engine, and then the engine then executes and then returns any response that gets generated by your runner. In the case of system events, these just come in from the system, and we sort of hard code these. So in the case of like remote notifications, we're basically listening for the relevant APIs on Android and iOS. And then when you get a silent notification, we then tell the runner that, hey, a silent notification has just been received. We take the arguments from that, put them in the dictionary, and then we send them down through dispatch event into your runner.
Okay. That's really cool. That seems like it works really well. And I like that you can call them both, like, have the system trigger it, but also be able to just like manually invoke these from your app. So
Right.
and you had like a data processing, something that's super heavy, right?
Exactly.
This is essentially offloading it from your UI thread, right?
Exactly. Yep. That's exactly the thought process behind being able to do it from your app.
Very, very cool.
Now, Joe, you said preferences API was one of the ones that'd be shipped with. Can you explain a little bit more? Is that like the devices like preferences application, or is it more like, I guess just dive into that a little bit?
Yeah. So we rely on the same native APIs that the preferences capacitor plugin does. So essentially on iOS, it's user defaults, and on Android, it's system preferences. So basically, it essentially functions as a very like basic key value store.
Got it. So that was KV then in the
Yep.
the
Example.
Got it.
Awesome. All right, so let's talk about your next slide here.
Yeah, so
a little more into the background runner.
Yeah, so this gets into a little bit more detail on what actually happens in the background runner plugin. So when you evoke events from your application, essentially it basically calls dispatch event, and then what happens is we spin up essentially an instance of the JavaScript core runner and context on iOS, and on Android we're using QuickJS. We've ported QuickJS to Android, and we're basically spinning up a QuickJS VM and then executing the code within that. Now, in the case of I mentioned before, you could also schedule a background task. Well, in that scenario, what happens is if you've got the correct configuration set up for that, when the plugin loads, we basically automatically register and schedule your background task with the operating system. And then when the time comes for the OS to execute your task, we basically take the event you want to call, and then we essentially pass that through a dispatch event, and then we wake up your runner and then execute it as well. So,
all right. So I've seen this kind of come up in the chat a little bit. What are some of the limitations, right, that you're running into with this?
Yeah. So like I mentioned before, the runners are not long lived. So let's take silent notification as an example. So what happens is notification comes in, the system generates an event for that, passes the event to the background runner plugin. Your runner is awoken. So what happens is we basically create a JavaScript VM. We load your code into it, and then we basically emit the event to your code. And then if you've got an event registered for that, it'll run the function and then complete. And then once that's done, everything closes and goes away. So one of the things you have to keep in mind when you're writing runner code is that each event needs to completely do its job. You can't rely on like global state or anything like that. You've got to do your work, save your state like to preferences or to the file system or something, and then basically end it. And a lot of this is driven by limitations of the OS. So now in the case of iOS, typically you've got like 30 seconds to do your work and be done. And so that's sort of what drove the design for some of that. So.
Okay. Yeah. So can you talk a little more about those limitations on the operating system? Like you said, there's like 30 seconds on iOS.
Yeah. I think Android's a little bit more forgiving, but I believe it's the same there. One of the other limitations, especially in regards to scheduling a background task, is that, and this applies more to iOS, is that let's just say, for example, you want to run a background task that updates your data every 30 minutes. It's not going to be exactly 30 minutes. iOS is going to determine based on a bunch of other factors when to execute your background task. It'll be close to 30 minutes. In my testing, it's been in between like 30 minutes to like maybe every 2 or 3 hours. It's going to depend on what the operating system decides when to run your task. So, and we'll make all of these edge cases clear in the documentation at launch, but just keep that in mind when planning your runner.
Yeah, I've heard stories of apps getting flagged for like background runners running too long or consuming too much battery, that they'll get like flagged in your like developer portal, right?
Right, and not even that, but if you let's say if your work is taking longer than like 30 seconds to run, the next time your task is run, the system may not decide to run it, or may push back the interval before it decides to run it again. So so a lot of our design is to make hitting those limits less likely for the end user developer.
Yeah, that makes sense, right? You just got to work within those limitations that are provided by the operating system. Yeah,
right. Yeah,
those are things we can't get outside of.
Exactly. Yeah.
And then, I imagine that's also for the end user's protection, right? Like you don't want a background test that's just constantly running and draining your battery, right?
Right, and that's a common request too. A lot of developers will ask for ways to like have a service that just runs in the background 24/7. That's not really going to happen on a mobile device. Again, the operating system is going to determine when your task gets ran and how often. When you set an interval for like maybe like 5 minutes, an hour, 2 hours, it's sort of more like a request. It'll get as close as it can while respecting the user's battery life. If the user is doing something else CPU intensive, so on and so forth.
Yeah, that makes sense. It's nice that we don't have to deal with that, right? That the operating system handles all that for you, so that we're not responsible for that coordination.
Yeah.
Cool. Logan, Connor, either you guys have any questions?
Yeah, so not really a question. I guess this is more of a statement, but basically it's probably pretty good to stick within the design patterns of iOS and just kind of assume like do one thing, right? Or do like one specific thing or two specific things. Don't try to like take so much, right?
Exactly. Yeah. Yeah. Keep the runner simple. Essentially, get in, do your work, and then get out as fast as you possibly can.
Yeah, mine was also more of a statement. Like I wouldn't have thought about how obviously the operating system is got its own internal like scheduling process and needs to figure out the best spot that it can fit that work in. And so kind of that call out of saying, well, even though you've set it to be every 30 minutes, it might not be that. So having that in the back of your mind too is going to help you better plan your work accordingly to make sure that you aren't hyper dependent on that interval being 100% accurate. So that's a really good call out.
Yeah, I can imagine a scenario. I used to work on an app before I, started working here at Ionic, where we would take pictures in low network environments. And I imagine that something like this could be really helpful to, when you come back onto a network, right, upload a couple of pictures and then, interval that until they're all uploaded and then basically be done. That would be really cool. All right. So let's, this is really cool. I'm very excited for background tasks. So let's jump over to the other side of this, this demo. We're not quite to the demo yet. To the other side of this discussion, and let's talk about watch, and then we'll dive into the demo a little bit here. So Dan, this has kind of been your project from Jedi Days, right? Is figuring out how in the world to get Capacitor to run on a watch.
That's right. And I kind of had some funny ideas, and could you get the slides up?
Yeah.
Just talking a little bit about like the basic capability is right now we have a predefined set of controls, and this might sound like a downer, but we only have 2 right now, but they are kind of powerful. So this code example here of defining the watch UI basically says we have 2 text fields and a button. And the first line is just a simple plain text field that's not interactive or dynamic. So it just says capacitor watch. The next line though has the $ counter element on it. So in text fields, when if you precede a variable name with a $, the watch will, because you can transfer this watch state between the phone and the watch, that state will be translated. If the watch has the state, it'll translate it and translate $ counter into whatever the value is. And then the button on the third line basically has a label, which is the plus equals 1. And then on the right side, inc is the name of a function. So that function is something you'll build into the phone app side, and that will be called when you press that button. And now whenever we send the UI to the watch, it's saved to the watch. So the watch never depends on the phone being active. So you'll still have your complete UI at all times, and you can determine when changes and updates are sent. So next slide, please. So thank you, Swift UI. Basically, this is really enabled by Swift UI. We kind of do some magic to translate that watch UI string into what you see on the phone, and then also translate the variables and view state and so on and so forth. Plus, the reason this goes well with background tasks is because it lets us call specific methods. When the watch might not be foregrounded, but we might need to say, give the watch some data even though the watch isn't there. So background tasks will let you do those things dynamically, and it should feel like a full-on watch application. So I talked about we only have these 2 to start off with. Very simple translations. One of the reasons we haven't built more yet is we kind of wanted to get this out in the community and see what other controls they'd like to see. There is a pretty significant amount of work that goes into the translation layer, and obviously the limits. There are a lot of limits, there's no limits on what's possible, but it's really the limit of what we're translating into the phone UI. So let us know what you want to see. And then I think there's one more slide. Oh, go ahead, Dallas.
Yeah, no, I was just saying this is actually really cool. I'm excited to see what comes of this. We really see this watch plugin as very experimental. We think it's really cool. We'd see some use cases for it, but we're really interested to see, what does the community see in this, right? What are the use cases that are out there that maybe we don't see, and we can work together to build towards those.
I was gonna say, Dan, like you mentioned text and buttons being a downer. I'm trying to think of, well, how extravagant do we really want to get? you know, with these watch apps, with the interface being so tiny, I mean, those are two obviously the most instrumental pieces, but it would be interesting to see how creative people can get with what they can shove into this tiny interface.
Yeah, for sure. And like right now, we really do things in like a vertical line of stuff. Like doing stuff side to side is a little different. So also like coming up with a different way of doing like table structured layouts, for example. It's possible. It's like I said, it is a lot of work to produce the translation layer. So, but that's why we're putting this out here now.
All right. So we've pulled up limitations here. You should talk to us a little bit about the limitations of this.
So right now, standalone watch apps are not supported because Capacitor depends on a web view, and you can't really do a web view on the watch. That's it. It's unfortunate, but it is what it is. You cannot do standalone watch apps. We don't support complications or traditional watch extensions. If you're familiar with the detailed way of doing interacting with the watch from the native side, and complications. I'm not going to say right now they're not supported right now. I've been thinking of ideas on how we could possibly produce complications, but I need to dig into that technology a little bit more. And then, of course, the watch currently cannot execute any code independently. Anything you want to, any action you want to have happen has to happen on the phone itself, and when the app is well, it's not when the app is running because you do it with background tasks. So you have options. So that's why we're bringing these two together, is because of the tight coupling that they need and provide.
Yeah, it makes sense. So I'm interested to see a demo. I hear you got something prepared for us.
You are. Well, let's go to the demo here. Let me rearrange my windows a little bit. And then let's look at phone and a watch. So one of the limitations here is that you really need to do it on physical devices. And so I've set up this little rig here and just to show what's going on here. So because it's an older watch, I can't. It doesn't. It has to go into like screen off mode. Anyway, so we made this demo app called Fake Stocks, and it's kind of a simple little buy and sell stocks here. We have hi Dan. We have how much money. Oops, I'm covering it up. Sorry. We have how much money you have, the stocks you own, and when I originally concepted this demo, I wanted to have like background notifications to tell you when to buy and sell. We didn't get that far because it was pretty complicated, but we kind of have what we want to show here is the interaction with the watch. So when we get into the watch here, we bring up the app. We'll see that we have our two stocks here. We have our money. This is hard to do because I would like camera's way over here, and you see that these numbers are synchronized with the stock names and the numbers you own and the price that they're at right now. So we can change. We can go ahead and sell. Let's sell some of our TSLL. Let's sell 10 of them, and then hit confirm, and it'll do that update. And if you were watching closely, you'll see that the watch was updated at the same time as I hit the button on the phone.
Yeah, it was quick.
Yep, and that's all happening real time across the thing. And I also have these are buttons on the watch, so I can tap a button on the watch to sell one stock from the watch. So I'll hit Appy over here, and there you go. You can see it updated on both sides at roughly the same time. So I'll do it again so you can see it happen and happen and happen. Pretty cool, huh?
It's very low latency,
Yeah.
if any.
Yep.
That's cool. I was just thinking the same thing, Connor. I'm like, this is nifty. I like this.
Yeah. I like Tiffany's call out. She's like, demo result, accidentally bought 10,000 shares of Apple, messing around and bought Apple stock.
Well, it's APPI, which is hopefully not a real stock.
Yeah.
It's also not my real money, so that's important.
Accidentally becomes rich on the demo. Wouldn't hate that.
Oh, shucky darn.
Anyway,
Yeah.
so that's half the demo. So I'll pause there for a moment.
Yeah, I think that's really cool. So in that specific example, right, that's just the watch functionality, right? We haven't touched on background tasks at all.
Yep. So
That's the ability with the watch to communicate while the app is in the foreground.
So now I'm gonna switch to some code here, and right now we're looking at I have a function here that builds my watch UI, and you can kind of see that I have a lot of variables and things. I'm not going to get into all the details, but what I do want to get into is I'm going to add a button to the UI that's going to let us enable a background notification. So first I'm going to uncomment this line, and then I'm going to do a usual npm run build and cat sync to build the web app and get it out to Xcode. And then this will finish in a moment.
I got to call out. It's nice to see you using Vue. I think most of our examples, are always in Angular. If you're not Angular, then definitely React. I don't feel like you see many Vue examples on the Ionic stuff these days. So nice work using Vue.
Kill that, and then I'm going to run our app from Xcode, and then go back over here and switch back to all that. And as soon as the app updated, you see the watch UI updated as well and added our background notification. So what's cool here is, so as we talked about, we had limitations in background tasks, and getting a background task to run like at the snap of a finger is very difficult. So what we've kind of figured out, now this is still using the background execution mode. It's just I guess a little more real time because we're using the watch event to trigger the background runner. So when I hit the background notification button there, and in a moment you should see the notification pop up. So that was the background runner telling iOS to put up a push notification on the screen at the moment, or near the moment. Now, the thing is, if I sat here and tapped the background notification button over and over again, you might not get one immediately because I haven't done it in a little while. It happened pretty much immediately, but if we hammer it too hard, it will start to stop. So, but that's pretty cool.
Yeah. So I want to see some code for this. If you can pull that up, I want to see. First off, you showed uncommenting that line of code about how you're building the UI. Can you show us that a little more fully?
Yep. So basically, and actually, I'm going to go to my split screen here and try to. I guess I can't really make that too small. Actually, there. Actually, sorry, I'm gonna putz around a little bit here.
It's the fun of doing live streams, right? Doing it live, changing stuff on the fly. I think it's more fun to do them live like this.
Well, fortunately, I have a kind of cool camera here.
So you got one of the more complicated setups of all this year.
Yeah, definitely.
Yeah. Oops. There we go. So now I have it so you can see the watch and the screen at the same time, so I can kind of talk through the code. No, that's fine. Oh yeah, okay, yes, because this is actually a scroll view on the watch, right? So what we have here is our text line, which is stocks. So you can see that. Actually, I can't really. I'm trying to point at stuff on different screens here. This is a messy arrangement. Anyway, so in here you see this text line stock. So that's the very top line. Then we have another text line with $sign and the user's cache. So that's a variable from the state we maintain in this app. And then we have a list of for each stock that the user has. We generate a button with a kind of dynamic label with all the. I'll break this down a little bit more. The name, the quantity the user owns, and then we're building this. This is the price. So the at price here, and then that's the first parameter in the button. That's what generates the label, and then the second parameter is the command. So what we have here is the word sell plus the ID of the stock or the user stock. So the backend is maintaining a user stock with a record ID. So what that's saying is we're going to sell the stock with that user ID. And then if we go into homepage and okay, so in the homepage we added a listener called for run command. So this is part of the Watch API that that executes commands. So I'm logging that the phone got a command and then the data of the command, and then I'm running the command. So the command looks like this. So I did everything with GUIDs. So it looks like the word sell plus the ID. So then to do that, to perform the sale, I'll parse the substring of the command. So now I only have the GUID. I'll go get the stock from the user stocks, and then I'll use the method that we have in the data store to sell that stock. And that's how that works. And then the background task thing is a little different. When we go back here, I have another command. So I have a button and with this background notification text, and then this command, bg notify. So bg notify is a little different in that that is defined in runner.js. So in runner.js, this or Joey, do you want to talk through this?
Yeah. So similar to the example I showed earlier. So I mean, this is an example of a basic runner. So and in this case, we're listening to an event called watch connectivity did receive user info. So this is a built-in event that gets triggered whenever the watch sends user info from the watch to the phone. So essentially what we've got here is a function that then responds to that. It pulls the JS command that he sent from the watch, which is called bg notify actually. And then as you can see, we're basically invoking or scheduling a push notification as a result of that.
Yep. And it's all well, this is a TypeScript, but JavaScript code. It's all very straightforward. Actually, I guess this is JavaScript here. And yeah, any web dev can do this. One thing I'll note is that in the native Watch API, there's 3 different methods. User info. Oh crap, I forgot.
Send message is the other one.
Yeah, messages. There's messages and action data. Or anyway, we'll basically have support for all of those methods because there's different conditions you want to use them in based on where the watch or the state of the watch and the phone being active. So we have support for all of those methods, and we're going to document it a bit so you don't have to look at Apple's documentation, which can be a little challenging. So
Joey, I'm curious here, right? We have this capacitor notifications call. Dan, if you wouldn't mind just pulling that back up real quick.
Oh, yeah.
This capacitor notifications, I don't see that imported anywhere. So is that just globally available to the runner?
Yep. So all of the capacitor device level APIs will be globally available to any runner code that's being executed.
Okay, that's really cool. So then we've created this runner.js file for our background tasks. Where does this get registered for background? Like, how does Capacitor know to use this as a runner?
Yep. So if Dan, if you open up capacitor config file there. So in the plugin object, basically you will define settings for your runner here. So essentially, what you're doing is you're giving it a label. And our documentation will go into this later, but the label will be crucial in scenarios where you're actually registering a background task. But of course, you can define your label. You can define the source of where the runner.js is. Currently, this is all very hacky right now. We'll as we continue to develop this out, we'll make it a little bit more developer friendly in terms of like defining your runner files and building them in case if you want to use TypeScript. But there are additional options. There is one called interval. So you basically define in seconds how often you want your runner to execute. There is an option called auto start, I believe. So essentially, what that means is when your app starts for the first time, it will automatically register and schedule this particular runner here as a background task. So this is essentially the basics. What you need to use the runner at all will just be the label and basically the source file for your runner.
And within that runner file, Joey, I noticed that, or at least kind of, I forget exactly where it was. Maybe it was in the view side where we were just calling BG notify, but because these two are linked together, it knows to listen to the did receive info or whatever. So that's really the operating system is controlling that message and sort of doing the magic side of this, right? Like, I guess maybe explain that a little bit more because.
Yeah. So the event, the watch connectivity event. So these are the runner basically sets up the appropriate delegates for the watch connectivity APIs, and then for we listen on our end for those events, and then we basically take them and then redispatch them as events to the runner.
Okay.
Basically, we've kind of obfuscated all of the stuff into easier to use things.
And the actual UI that you're building, those are just Swift UI elements, right? The text and the button. Those are
right. They emerge as from our, so this button, this text, that's our language, and then we translate it on the watch side into Swift UI elements that get slapped together.
Okay, so let's jump back over to the runner real quick and take a look at this. So in terms of background tests, right? I see the first one on here is just like it's a test, right? Basically an echo, make sure everything is up and running. So if we were to look at this and say, okay, well, I want to call this from my app code, right? How do I do that?
So from your app code, you would basically import the background runner as if you were importing any other capacitor plugin, and then there will be a function on that called dispatch event, and basically essentially all you do is you give it an event name. So let's say you wanted to invoke the test event, you would give it test as the event name, and then if there was any additional details you wanted to send over as a JSON object, you would then also define that as additional arguments, and then the plugin will then basically asynchronously execute your event and then return back any arguments that you need to return back. So in that args completed function, you can also pass an object that will then be sent back to your web.
That's really cool. So you can do data both to the events as well as back from the events to the caller.
Yeah. Also, it respects exceptions. So if something gets thrown within your event listener, it will get bubbled up back to your web app. So it would basically be a throwing error. The promise that gets executed when you run dispatch event will then resolve as an error.
Okay. Excuse me. That's really exciting. I see this opening up so many possibilities for capacitor applications, right? Just brand new. It's a brand new area, right? For people to go in and really explore this space of, what can capacitor applications do in the background now? I think that just, it shows, what the power of Capacitor is, right? It's not just a simple web view doing the very basics, right? This is being able to really go the extra mile and provide that top tier experience for the end users while providing, a great and easy experience for the developers. So cool. Any other comments from Connor, Logan? You guys got anything?
I just think this is really cool. I like, to your point, Dallas, I just feel like there's so much that you could do with this. I saw one comment from Damien talking about like getting blood sugar readings. So like being able to integrate this with Apple Health and getting like real-time notifications from Apple Health and being able to display it in the background. I think that's pretty powerful stuff when you can integrate it with other features that, you can build out through Capacitor.
Yeah.
Yeah, my head just started spinning on different use cases, past and present, on where we could take this. And you guys have done a nice job of kind of leaving it open, right? Like with the parameter infrastructure of just like, you can really do anything and whatever you want. So it really is endless, kind of what we could do here, and it'll be exciting to see where people take it.
Yeah, so there's been a couple of comments. I think this is a good chance to kind of look through this. And I know a couple of the other Capacitor engineers have been in answering questions. Thanks, guys. Here's another example, right, from Chris, right? Things you can do in the background. Maybe you want to do your own Fitbit competitor. You can build it with Capacitor, right? track people's runs, record their speed, where they're at. This is a great idea, I think. Let's see, what other comments do we have in here to call out?
I'm going to note one other plugin idea I've had that I haven't really started to implement yet is a Health Kit plugin.
Ooh.
Yeah, Health Kit would be really cool. Let's see. So here's a good one, I think, from Tobias. Hopefully I get the names right. So do you register the scheduled task for custom seconds? I think you talked about this, right? Every 2 minutes, or is it always 30 seconds, right?
Yeah, so 30 seconds is the amount of time you have to do your work before your task is terminated. You can schedule your task to run how often you want. In reality, I believe the minimum on iOS is either a minute or 5 minutes in between invocations. And on Android, I believe it's also the same. I think 5 to 10 minutes is the minimum.
Okay.
Yeah, it's really we're kind of at the operating system's mercy. That's really the big thing to keep in mind. And like we're going to try to document a lot of the, instead of having to go to Apple or Google's documentation, we'll try to document as much as we can in our documentation. So that it can help everyone out without having to search, 3 different documentation sites to try to get your thing done, right?
Yeah, so let's talk this here. So we've mentioned that there are 3 APIs available that we plan to release with initially. So that's preferences, key value storage, geolocation, and local notifications. So we have Will here asking, does background runners, do they have access to other Capacitor plugins like, say, SQLite?
Currently, no. Theoretically, it's possible in the future.
One of the limitations here is that the background runner is using its own runtime, so it's not exactly JavaScript. Some of the things in the background runner have been basically custom coded by Joey in C. So it's a tremendously complicated plugin, but we are, putting this out there to get feedback and see what we can build and more.
Yeah, and one limitation as well that prevents, say, the current capacitor geolocation plugins from working within the background runner version is that the capacitor plugins rely often on the web view, and we can't. There's no guarantee of the web view being available when the background runner is executing. So that's one of the reasons why we can't necessarily currently use the capacitor plugins as they are now, but we're thinking about this, so just stay tuned.
Yeah, Yeah, and I think that makes sense, right? So like the point of the background runner is that perhaps the web view is available, right? If you're invoking it from within your application, but there's also the opportunity that it could be running at 2 a.m. when the phone is, nothing is running. It's sitting on the charger, doing whatever. And so in that moment, there is no web view, or if the app is even open, right, it's backgrounded, which means that web view is frozen. It can't do anything. So even if it is there, it's still, you can't use it. And so I imagine this goes with the same comment from Glenn, right? Plans to add like Bluetooth, low energy, BLE background. Same boat, right? Where existing plugins likely are tied to that web view in some capacity, and they would need to be re-architected to follow this new architecture so that they work within the runner. Here you go. Shout out to Dan and Joey from Scott. Awesome. I think it's a great sentiment, right? I think this is the feeling that's coming from the community about this. And I think this is the thing that people are really excited for. There was one other question. Let's see. Scott's been pretty chatty in I'm going to highlight him again. I need this badly. Right? I need to track my user and show that on Google Maps. When will it be released? We're highlighting you, Scott. Thanks for chatting with us. When's it going to be released? So this is the thing we're excited for.
So the last, I
got it right here. So we are currently planning to make these public as part of the Ionic show. So we have an Ionic show coming up. We do these every quarter, right? Where we talk about everything that's new and coming with Ionic. Tune in because we're going to talk about these and these specific plugins. We're going to talk about releasing them to everyone. The other cool thing that I don't think we've mentioned, right? If you were looking, you might have seen that some of these plugins were listed as Ionic Enterprise, right? It's because they're private right now. We fully intend that both of these plugins, both the background runner and the watch plugin, will be open source and part of the Capacitor core offering as part of the ecosystem. So we're excited that they're going to be a part of the ecosystem as a whole. They'll be available for everyone to use. We just think there's too much value here, right? This is something that everyone can use, and we want everyone to be using it so that they can have that best experience possible. So these will be coming available to everyone, and then we'll be talking about the exact release at the Ionic show, which is just in a few weeks.
That's right.
Super excited. Yeah.
I just wanted to say thank you to Dan and Joey for kind of taking us behind the scenes here. It's cool to see what you guys are doing, behind the scenes and outside of what, can share in meetings. And of course, these are Jedi Day projects. So these are things you're kind of doing sporadically throughout, between your sprints. And so it's really cool to get a glance into some of these skunkworks projects that are going on in the Ionic land, and eventually how those kind of make it out into production. And this is a good example of just that. So appreciate you guys jumping on to show everyone that.
Both of these projects have been underway for the better part of the last year.
Yeah. They're both major undertakings. We're really excited we get to talk about them now. It's going to be great. For people who are here, if you want to keep talking with Dan and Joey, right, you have some other questions you think about in the next day or two, QR over there, QR code, right? That's our Discord. There's also this link here down below, ionic.link/Discord. This Friday, as part of Capacitor Month, all of the Capacitor engineering team is going to be in our Discord, hanging out with people, answering questions. So if you want to dive into more detail about background tasks, if you want to learn more about Capacitor Watch, come hang out with us. We love to chat with people and answer questions. We are on there at 12 o'clock Central Time, which is about the same time we start this live stream. But you can also submit questions ahead of time. Just drop them in any of the Capacitor channels, and we'll go back through and make sure we'll do our best to get answers on everybody's questions that come in there. But yeah, definitely come hang out with us. Scan the code. Come hang out with us in Discord. It's fun. We like to hang out in Discord.
That's right.
All right. Well, I think that's going to be everything for today. And we just ticked to the hour mark on our live stream. So we are right on time. Shout out to the community. You guys are great. Thanks for coming and hanging out with us, chatting with us. and supporting with us. We hope you continue to enjoy using Capacitor, and we look forward to chatting with y'all in the future. Hope you all have a great day.
Take care, everyone.
See you later, y'all.